Good morning, everyone. My name is Karthik from Center for Defense Careers. Today, we will be solving ND2 2024 physics section from General Ability Test paper. This will be set A paper. Now, before we start solving the paper, let's look at the analysis of the paper. As we had discussed in our class, force, motion, current, electricity, and optics carry the maximum weightage. We had mentioned this again and again in the class that if you study these chapters in depth, then you can score maximum marks. Okay, and it is evident from this table. Now let's move on to solving the paper. Okay, the very first question is we have two resistances, 5 ohms and 7 ohms are connected in series. Okay, let's draw two resistances, 5 ohms and 7 ohms. Let's say this is 5 ohms and this is 7 ohms are connected in series. Now this combination is connected in parallel with a 36 ohm resistor. Okay, now let's draw a 36 ohm resistor here. Okay, we have to find out the equivalent resistance. That is nothing but the total resistance. Now we had done a very similar problem in our classroom. Okay, so let's look at the solution. First of all, we'll start by solving these two series resistances. Okay, so we get series resistance RS equal to 5 plus 7, that is equal to 12 ohms. Okay, now these two resistances are connected in parallel. Okay, so let's apply the parallel resistance formula. So we get 1 upon 12 plus 1 upon 36. So we get 3 upon 36 plus 1 upon 36. So it will be equal to 3 plus 1 upon 36. So 1 upon Rp will be equal to 4 upon 36. So Rp will be equal to 36 divided by 4, and that will be 9 ohms. So the correct answer will be 9. Moving on to the next question. An astronaut whose weight on Earth is 600 Newton experiences weightlessness on International Space Station. Okay, we had done a very similar problem in our classwork. In the classwork, we had done a person standing inside the lift. It is very similar to the problem seen in the screen. Let's solve it in a very similar way. Okay, so we have an astronaut. Now, astronaut has some weight, and because of the weight, he exerts a force mg. And from Newton's third law, we know that there is a reaction force from the space shuttle on the astronaut, and that reaction force is N. Now, the astronaut in the space shuttle is freely falling towards the Earth. Okay, but freely falling towards the Earth with acceleration equal to g. Now, summation of all the forces, that is net force, will be equal to mg minus n. Okay, mg minus n. Now, according to the Newton's first law, we get force is equal to mass times acceleration. Here, acceleration is equal to the acceleration due to gravity. So instead of writing ma, we'll write mg. So mg will be equal to mg minus n. So n will be equal to mg minus mg. So we get n equal to 0. Okay, n equal to 0. So the normal reaction of the space station on the space station floor on the astronaut is 0. This will be the correct answer. Now option C will be wrong because if there is no gravitational pull, then the space station will not be orbiting the Earth. So option C is eliminated. Space station applies centrifugal force. Now, in order to perform orbital motion, we require centripetal and not centrifugal. So this option is also eliminated. And acceleration of the astronaut is 0. In the option A is also wrong because acceleration of the astronaut is equal to the acceleration due to gravity. Now moving on to the next question. We have, which of the following statement gives the characteristics of contact forces? Now the very important thing about contact forces is that it requires contact between two different objects. Okay, so let's look at the first option. The first option says it appears between object when it is in contact with some other object. Yes, this is the fundamental requirement of contact forces. Now, what is the second option? It satisfies the third law of motion. Yes, third law of motion is applicable for contact forces. Now, what is the third option? It may appear between pair of solid and fluid. Yes, and these contact forces between solid and fluid are called as adhesive and cohesive forces. Okay, adhesive and cohesive forces. So this is also true. So the correct answer will be option D. That is 1, 2, and 3. Now moving on to the next question. So we have which of the following figures correctly represents the ray diagram? Now let's start with option A. Here the object is at focus. Now I have mentioned multiple times in our classroom that whenever the object is at infinity, image always forms at infinity. In option A, the object is forming at the focus, which is wrong. Okay, now let's look at the second option. Here, the object is at 2F. Now, 2F is nothing but center of curvature. Okay, 2F is nothing but center of curvature. If the object is at the center of curvature, the image always forms at the center of curvature and it is the same size as the object. So this option is the correct one. We had done this problem again and again multiple times in our classrooms. Now let's look at option C and D and understand why they are wrong. Now, in option C, the object is at the center of curvature, but the rays are going towards infinity. This can only happen when the object is at focus and not at center of curvature. So this is also wrong. And in option D, the object is at center of curvature. The image is also forming at the center of curvature. But in order to form an image, the rays have to meet. Here, the rays are meeting at 2 points, here and here. In order to form a sharp, clear image, rays only meet one time. In option B, the rays are meeting 2 times. So this is also eliminated out. So the correct answer will be option B. Moving on to the next question. We have lightning is due to the flow of charges between different parts of the cloud. Now, generally, lightning occurs when there is flow of charges between different parts of different clouds. Okay, different parts of different clouds. Now here they have mentioned same cloud. They have not mentioned different cloud, so we have to assume that it is between inside the same cloud. So this option is eliminated because lightning generally occurs between two different clouds, not in the same cloud. Okay, the short circuit of charges between the upper and lower surface of the cloud. Again, this does not happen. Now let's move on to the third option. The collection of positively charged particles at the base and collection of negatively charged particles at the top of the cloud. Now, when the lightning occurs, generally the positive charges are at the top of the cloud and negative charges are at the bottom of the cloud. Here in the option, they have mentioned that the positive charges are at the base, which makes this option wrong. Now, if we look at the option D, the induction of positive charges on the ground below the negative charges at the base of the cloud. Yes, this is what occurs. Now, the negative charges at the bottom of the cloud attract the positive charges at the top of the ground. Now, because of the accumulation of these charges, there is a very strong electric field between the ground and the earth. Now, if the electric field is sufficiently strong, the resistance of the air can be overcome and hence there is a flow of charges which we call as lightning. So option number D is correct. Moving on to the next question. We have, in which of the following situations the bulb will glow brightly? So in order for the bulb to glow brightly, we require maximum voltage and minimum resistance. And minimum resistance occurs in case of parallel connection. In parallel connection, we have minimum resistance. So in the very first option, you can see the two bulbs, 1 and 2, are connected in series, which means they will have very high resistance. And because of very high resistance, they will not glow brightly. So we'll eliminate option A. Now, if you look at option B, again, the bulbs are connected in series, which means they will have high resistance. Even though they have high voltage connected across them, we still have high resistance because of series connection. So let's eliminate option B. Now, if you look at option C, there is one single bulb and one single voltage. So yes, in this case, maybe the bulb will glow brightly. Let's look at the next option and then come back to this. In option D, we have two bulbs, 1 and 2, connected in parallel, which means the resistance is low. And at the same time, they are connected to a very high resistance voltage. So in this case, in option D, both the bulbs will glow with maximum brightness. Hence, we'll go with option D. Moving on to the next question. Okay, which of the following sketches correctly describes liver of second class? Okay, for a liver of second class, we have fulcrum at the end. Okay, fulcrum at one end, and fulcrum can also be called as pivot. Okay, so we have fulcrum at one end, we have load at the center, and then we have the effort. Okay, a very similar problem effort at the very last. relatable example will be nutcracker, or similar to a nutcracker, we use a device to bring out the juice of lemon. Okay, so that will be an example of second class lever. So you can clearly see option number C matches this diagram. So option C will be the correct example. Now moving on to the next question. We have an electric circuit given below. The correct combination of voltage and current will be. Okay, so here voltage is connected. We can clearly see that all three resistors are connected in parallel. In parallel connection, voltage across each of the resistance is same. So the voltage V across 100 ohms and voltage across 200 ohms, voltage across 300 ohms, all three of them are same. So let's calculate. Now let's apply for 100 ohms. Let's apply Ohm's law. So we get V equal to IR. Now you can clearly see here the current across the 100 ohm resistor is 3 amperes. So the voltage will be 3 into the resistance is 100 ohms. So we get V equal to 300 volts. So the voltage is 300 volts. Now the same 300 volt is shared by 200 ohm resistor and 300 ohm resistor. That is the voltage across this and this will be same. Now they have asked us to find out I. I is the total current. Now in order to find out the total current, first we will find out the total resistance. So let's find out the total resistance. That will be 1 upon Rp will be equal to 1 upon 100 plus 1 upon 200 plus 1 upon 300. So 1 upon Rp will be equal to 1 upon 100, and this will be 1 plus 1 by 2, and this will be 1 by 3. So I get 1 upon Rp will be equal to 1 upon 100. This will be equal to 3 by 2 plus 1 by 3. So we get 1 upon Rp will be equal to 1 upon 100, and this will be equal to 9 plus 2 divided by 6. So I get 1 upon Rp will be equal to 11 upon 600. So Rp will be equal to 600 ohm divided by 11. Okay, so this is the total resistance. Now let's apply the Ohm's law for entire circuit. So we get V equal to IR. So the total voltage is 300 volts, current is 600 divided by 11, and resistance, okay, sorry, the resistance is 600 by 11 and the current is I. Now this will be 2 times, this will be 1 time, 1 time. So this will be 1 time. So we get current equal to 11 by 2, that is 5.5 amperes. So option B will be the correct answer. Moving on to the next question. Yet a point object is placed at the center of curvature. If the object is at center of curvature, as discussed multiple times in our classroom, if the object is at center of curvature, it does not matter whether it is a mirror system, it is a lens system. If the object is at the center of curvature, then the image will always form at the center of curvature and it will be the same size. So here the option B will be correct answer. Moving on to the next question. Which of the following is correct for a person suffering from myopia? Okay, a person suffering from myopia is also called as nearsightedness. Okay, nearsightedness. That means the person is clearly able to see objects that are nearer to them and has difficult time seeing objects that are far away. Okay, so a person suffering from myopia can clearly see objects that are near to them. So option A will be the correct answer. Now, we have a vehicle starts moving along a straight line path from rest. In the first t seconds, it moves with an acceleration of 2 meters per second square. And then in the next 10 seconds, it moves with an acceleration of 5 meters per second square. The total distance traveled by the vehicle is 550 meters. The value of time t is, okay. So what we're going to do is, this is the straight line path. Okay, the total distance traveled by the car is 550 meters. Now let's divide this into 2 phases. In phase 1, the object is traveling in t seconds. Okay. In phase 2, the object is traveling in 10 seconds. Okay. So in first phase, it starts from rest. So its initial velocity is 0 meter per second. And the acceleration here is 2 meter per second square. And the time given is t seconds. Let's say the displacement is S1. Now, using the equations of motion, we get S1 equal to U1t plus half A1 T1 square. So we get S1. Now, since U1 is equal to 0, this entire term becomes 0. We have half A1 is 2 and T1 is T square. So we can cancel these two and then we get S1 equal to T square. So let's call this equation 1. Now, for the second phase, we have for the second phase, U1 the initial velocity for the second phase will be the final velocity of the first phase. So the initial velocity of the initial velocity for the second phase will be the final velocity of the first phase. So let's find out the final velocity of first phase. So using the equations of motion, we get V1 equal to U1 plus A1 T1. V1, since U1 is 0, this becomes 0. A1 is equal to 2 and T1 is equal to T. So we have V1 equal to 2T. Now this V1 will be equal to the U2. That is, the final velocity of phase 1 will be equal to the initial velocity of phase 2. Now here the acceleration A2 is equal to 5 meter per second square and the time T2 is equal to 10 seconds. Okay, let's find out the displacement using the equations of motion. So we get S2 equal to plus half A2 T2 square. So we have S2 is equal to U2 is equal to V1. V1 is equal to 2T. So we have 2T and this is 10 plus half A2 is 5 and this is 10 square. So we get S2 equal to 20T plus half into 5 into 100. So we can cancel these two, we get 50. So S2 will be equal to 20T plus 250. Okay. Now the total distance S, let's call this equation 2. Our total distance will be S will be equal to S1 plus S2. So S will become from 1 and 2, we can write S1 is equal to T square. And from equation number 2, we can write 20T plus 250. And we know that S is equal to 550 equal to T square plus 20T plus 250. Now taking the 550 on other side, we get 0 equal to T square plus 20T plus 250 minus 550. So we get 0 equal to T square plus 20T and this will be equal to minus 300. Now let's solve this quadratic equation. So we get 0 equal to T square. We can write this as plus 30T minus 10T minus 300. So we get 0 equal to T common. So we get T plus 30 and here we can take 10 as common. We get T plus 30. So we get 0 equal to T minus 10 and we get T plus 30. So we get T equal to 10 seconds. So the correct answer will be T equal to 10 seconds. In the other one, we get 3 equal to minus 30 seconds. Time cannot be negative. So we will eliminate this option out. We get T equal to 10 seconds. So correct answer will be A. Moving on to the next question, we have an incandescent electric bulb converts 20% of its power into light. Okay, 20% of its power into light. The remaining power is dissipated as heat. The bulb's filament has resistance equal to 200 ohms and current equal to 2 amperes flow through it. If the bulb remains on for 10 hours, the rate of electric charge is 5 rupees per unit. Then which of the following is the correct? Okay, we have done a very similar kind of problem in our class. Now let's look at the solution. So power is equal to, we have resistance and current. We can write this as I square R. So power will be equal to 2 square into R, that is 200 ohms. So we get power equal to 4 into 200. So we get power equal to 800 watts. Now let's convert this into number of units. So number of units is very simple. Let's divide this by 1000. So we get 800 divided by 1000. So we get These two zeros cancel out. We have 4 and we have 5. So we have 4 by 5 units. Now out of this unit, only 20% of it is useful. So let's only take the 20% part. So 20% will be 4 by 5 into 20 divided by 20% can be written as 20 divided by 100. Now the zeros cancel out. So we get 8 divided by 50, which we can write 4 divided by 25. So out of the 4 by 5 units, only 20% is actually useful, and we have to only find out the value of producing light. So we have taken out of the 4 by 5 units, we have taken 20% of it, which we get as 4 divided by 25. Now we have to run it for, the bulbs run for 10 hours. Okay. So in 10 hours, how much unit is consumed? So we can write this as 5 and this can become 2. So we get 8 by 5 units consumed in 10 hours. So in 10 hours, the electric bulb consumes 8 by 5 units. Okay. So let's calculate the cost. The cost will be units consumed, that is 8 by 5 multiplied by the cost of per unit, that is 5. We can cancel each other out. We get 8 rupees. So the correct answer will be option D. Now moving on to the next question we have. 96. A car weighs 1000 kilograms. Okay, mass of car is 1000 kilograms. It is moving with a uniform velocity of 72 kilometers per hour. Okay, the initial velocity is 72 kilometers per hour. Now we have to convert this into SI units. So 72 into 5 by 18. So we get 1 times, we get 4 times. So this will be equal to 20 meter per second. So initial velocity of the car will be 20 meter per second. Okay. The driver suddenly presses the brake. The car stops in time 0.2 second. The retarding force applied. So we had done a very similar problem in our classwork. Now let's do it. Okay. According to Newton's second law of motion, we know that force is equal to mass times acceleration. And acceleration can be written as change in velocity divided by time. Now change in velocity will be final velocity minus the initial velocity divided by time. The mass is 1000 and the final velocity, since the car stops, is 0. Okay, since the car stops, final velocity will be equal to 0 and initial velocity is 20 divided by the total time is 0.2. So we get 1000 multiplied by minus 20 divided by 0.2. Okay, let's cancel this out. Then we'll get 100. So we get 100 negative 100 kilonewtons of force. Okay, so the correct answer will be option D. 100 kilonewtons of force. Moving on to the next question. So we have, there is a ball of mass 320 grams. Okay, mass of the ball is 320 grams. Now this can be written as 0.320 kilogram. Okay, it has potential energy is given as 625 joules when it is freely released from a height. The speed with which it will hit the ground. Again, we have done a very similar problem in our class. So let's apply the conservation of energy. So we get potential energy is equal to kinetic energy. So the potential energy is 625. Formula for kinetic energy is half mv square. So we get 625 into 2, mass is 0.320 and velocity is v square. So we can write 625 into 2 divided by 0.320 will be equal to v square. So this will be 0.160. So v square will be equal to 625 divided by 0.160. Now we can write this as 625 into 100 divided by 16. Okay, so V will be equal to square root of 625 into 100 divided by 16. So this will be 25 divided by 4 into 10. So 1 times, and this will be equal to 4, 6 and 6 0.25. So this will be equal to 62.5 meter per second. So the velocity will be 62.5 meter per second. Correct answer is option A. Moving on to the next question. Starting from rest, a vehicle accelerates at the rate of 2 meter per second square. Okay, it is starting from rest. So the initial velocity will be equal to 0 meter per second. It accelerates at the rate of, okay, acceleration is 2 meter per second square towards east for 10 seconds. Okay, let's say this is the values and we have 10 seconds. It then stops suddenly. That means the final velocity is 0 meter per second. It then accelerates again at the rate of, okay, we have another acceleration for root 2 meter per second square for the next 10 seconds. Okay, we have time 10 seconds towards the south and then again comes to rest. So the final velocity is again equal to 0 meter per second. And since it starts from 0 velocity, so the initial velocity is also equal to 0 meter per second. The net displacement. Okay, so it initially moves in the east direction and then it moves in the west direction. Let's say the displacement during the first phase was S1 and the displacement during the second phase was S2. They've asked you for the net displacement. This is A, let's call this point B, and let's call this point C. So we have to find out the net displacement. Okay, so we have to basically find the AC. So for that, we have to first calculate S1 and S2. So let's apply the equations of motion. So we have S1 equal to U1T plus half A1 T1 square. So we have S1 equal to, since this is 0, you can apply 0, this will be a half, and A is equal to T and time is 100 square. So we can cancel this answer, sorry, 10 square. So this will be equal to, S1 will be equal to 100 meters. Similarly, let's calculate S2. So we get S2 is equal to, we get U2T plus half A2T2 square. So S2 will be equal to 0 plus half. We get 4 root 2 into 10 square. So we get S2 equal to, these two cancel, we get 2 root 2 into 100. This is S2 is equal to 200 root 2 meters. Okay, so let's calculate AC now. Now applying Pythagoras theorem, we get, I'm going to solve it here. Applying Pythagoras, we get AC square will be equal to S1 square plus S2 square. And that will be equal to 100 square plus 200 root 2 square. Okay, so AC square will be equal to 100 square will be 10 raised to 4 and 200 square will be 400 4 into 10 raised to 4 into 2. So that will be, let's take 4 as common. So we get 4 plus 1. Okay, sorry. We can write this as 1 plus 8 and taking 10 raised to 4 common. We get 9 into 10 raised to 4 as AC square. Okay, 9 into 10. Now taking square root on both sides, we get 3 into 10 raised to 2. That will be equal to 300 meters. So the correct answer will be 300 meters. Okay, now moving on to the next question. We have, which of the following is the correct focal length for the combination of power lenses, that is plus 2.5 diopter and minus 2 diopter. Okay, so let's find out the power for the, we have the power for the first lens. Let's find out the focal length. So F1 will be equal to 1 upon P1. That will be equal to 1 upon 2.5. I can write this as 1 upon 5 by 2. Let's write this as 2 by 5. So we get 0.4 meters first focal length. Similarly, let's find out the second focal length. That will be 1 upon P2. That will be equal to 1 upon minus 2 and that will be equal to minus 0.5 meters. Now the total focal length will be 1 upon F will be equal to 1 upon F1 plus 1 upon F2. So that will be 1 upon 0.4 minus 1 upon 0.5. Solving this, 0.5 minus 0.4 divided by 0.2. This will be equal to 0.1 divided by 0.2, 1 upon F. So F can be written as 0.2 divided by 0.1, which will be plus 2 meters. So the correct answer will be option number C, that is plus 2 meters. Moving on to the next question. We have the AC means domestic supply current in India changes direction. Okay, in India, we have discussed this question in our class. In India, the frequency of AC supply is 50 hertz. Okay, the frequency is 50 hertz. So the time period will be 1 upon frequency, that is 1 upon 50. So in every 1 by 50 seconds, the cycle switches from positive to negative, then again positive to negative. So this happens in 1 by 50 seconds. So the correct answer will be option B. Moving on to the next question. Shown in the figure are two hollow cubes, C1 and C2, of negligible mass, partially filled, excuse me, excuse me, partially filled with liquids of densities rho1 and rho2. Okay, this solution has density rho1 and this solution has density rho2. Floating in water, the relationship between rho1 and rho2. Now, since they are floating, obviously water is the denser material here and other two are lighter material. So the density of water will be the greatest. Okay, now you can clearly see from this image that the cube C2 is deeper inside the water. That means it will have a higher density compared to C1. So C1 has the lowest density and then we have C2. Now here option C matches the answer. So we go with option C. Moving on to the next question. A block of mass 2 kilogram. Okay, a block of mass 2 kilogram. Mass is 2 kilograms. Slides on a rough horizontal surface. Let the speed of the block at a particular instant, that is initial velocity, is given as 10 meter per second. It comes to rest. Okay, final velocity is 0 meter per second after traveling a distance of 20 meters. Which of the following could be the magnitude of frictional force? Okay. So for force, from Newton's second law, we know that force is equal to mass into acceleration. So first thing we have to do is find out the acceleration. Now let's make use of equations of motion. That is V equal to U plus AT. Now final velocity is 0, initial velocity is 10, and the acceleration is, we don't know, and the time given is, do we have the time? Okay, so we cannot make use of this one. Let's make use of the other equations of motion, that is V square equal to 2AS. So V square, since it is 0, this will be 0 square, and the initial velocity is 10 square plus 2 into the acceleration is what we have to find out. Distance traveled is 20 meters. So we get 0 equal to 100 plus 40A. So minus 40A will be equal to 100 and A will be equal to 100 divided by 40. So we can cancel this out. We get 2 and this is 5. So acceleration is equal to 2.5 meter per second square. Now the force will be equal to, force is mass times acceleration. Force will be equal to, what is the mass? Mass is 2 kg and the acceleration is 2.5. So we get force equal to minus 5 newtons. And as you can clearly see, none of the options may match the answer. Now we have checked with multiple sources, multiple methods. The options do not match. That means here the options are wrong. The correct answer is 5 newtons. Moving on to the next question. We have, which of the following diagrams correctly represents the motion of skydiver jumping? Okay. So when the skydiver initially falls down, okay, when the skydiver initially falls down under acceleration gravity, his speed will continuously increase. Now, after a certain time, the skydiver will achieve terminal velocity. During terminal velocity, let's assume this circle is the skydiver. During terminal velocity, the frictional force due to air drag and the gravitational force will balance each other out and the speed will not further increase. So here we should see a plateau. Now, once the skydiver opens the parachute, the frictional force significantly increases and it drops the speed of the skydiver. Now, after some time again, the frictional force and the gravitational force will balance each other out, and you will get a terminal velocity. So you should get a sharp drop here. Now you can clearly see, okay, we have two options that could be the potential answers. Let's eliminate the wrong ones out. So we can either have option D or option A, but we should have a sharp drop at the very end, and that is only available in option A. So option A will be the correct answer. Okay, moving on to the next question. We have a pumpkin weighs 7.5 newtons. Okay, the mass of pumpkin, okay, weight of pumpkin. They have given us newtons, so it will be the weight of pumpkin. That will be 7.5 newtons. On submerging it completely in water, 3.3 by 4 liters of water gets displaced. So we get volume, that is 3 by 4 liters. Now let's convert this into SI units. So we have 3 by 4 into 10 raised to minus 3. So we get 3 by 4 into 10 raised to minus 3 kilogram per meter cube. Okay. Now gets displaced. The acceleration due to gravity, okay, at the place G is 10 meter per second square. Which of the following is the correct value of the density? So if this is the container and this is the fluid and this is the object, then when the object, because of the weight of the object, it applies a force downward, and because of buoyancy, the liquid will apply an upward force. So the formula for buoyancy will be FB equal to rho GB, where rho is density, G is the acceleration due to gravity, and V is the volume. So we have FB upwards and mass force because of weight downwards. So from the diagram, we can write F equal to FB. Now, because of mass, the force will be mg and buoyancy force will be rho gv. Okay, so we get these. Okay, they have given us mass. Okay, this will be mg. They have given us mass, that will be 7.5 newtons, and they have asked us to find out the density. So rho, and acceleration due to gravity is 10, and they have given us volume, that will be 3 by 4 into 10 raised to minus 3. Okay, now taking all the numbers on the other side, we get rho is equal to 7.5 into 4 divided by 10 into 3 into 10 raised to minus 3. Okay, so let's start solving. So we get, if we multiply 7.5 and 4, we get 25. Divide 25. Let's take the 10 by minus 3 up. We get 10 raised to 3. So we get here 30. So this will be 5 times. This will be 6 times. Okay, I've made some calculation mistake. Let's check. So we get rho GB is 3 by 4 into 10 raised to minus 3. Okay. Okay, so this will be, I'm extremely sorry, this is 30. So we get, let's do the calculation again. So rho is equal to 7.5 into 4 divided by 10 into 3 into 10 raised to minus 3. So this will be 30 divided by 30 into 10 raised to 3. These two cancel out. So density is 10 raised to 3 kilogram per meter cube. And that will be option C. Okay, so you have to do calculations very carefully, otherwise very small mistakes can give you negative marks. Now moving on to the next question. So which of the following statement best defines the concept of heat? So heat always flows when there is a difference of temperature. We have discussed this in our class. So let's look at the first option. So the transformation, okay, there is no transformation of energy when the heat flows. So option A is obviously eliminated. The conversion of heat into mass and vice versa. This is Einstein's formula, not based on heat. So let's eliminate this option also. So we have option number C, the transfer of heat due to temperature difference. Yes, this is the correct option. Now let's look at option D and understand why it is wrong. So in the option, we have change in volume. Okay, volume doesn't change. So option D is also eliminated out. The correct answer will be option C. Moving on to the next question. The masses of two planets are in the ratio of 1:1. The ratio of their diameters is 2:, okay, this is 1:7, I guess. Yes, 1:7. Okay, the ratio of their diameters is 2:1. The ratio of the force which, okay, now if you closely look at this question, It is extremely simple and you can do it in like 10 seconds to simply apply Newton's third law of motion. A third law of motion says that every action has equal and opposite reaction. So if there is a planet and there is another planet, if this planet exerts some force, let's say F1 on another planet, let's say the first planet is M1, the second planet is M2. If M1 is exerting some force F1 on M2, then M2 will also exert exactly same amount of force on M1. So force M1 will be equal to F2. And if you take the ratio of these two forces, then the answer will be 1. That is option C. Okay. According to third law of motion, let's repeat it. According to third law of motion, every action has equal and opposite reaction. So if M1 exerts force F1 on M2, then M2 will exert same equal amount of force, but opposite in direction on M1. The magnitude of both forces will be same. So here they have clearly asked us the ratio of forces. They have not asked us for direction. They've asked for ratio of forces, which is magnitude, and we get answer 1. Okay, both the forces will be equal to each other. Now moving on to the next question. We have given below are the 4 cases in which certain heat transfer is taking place. Okay, in which of the above case the Newton's law of cooling is applicable? Ice is melting in glass full of water. Here nothing is cooling, the ice is actually heating up. That is why it is converting into water. So this is here Newton's law of cooling will not be applicable. Water is boiling in an open container. Again, here water is reaching, the temperature is increasing. So here also Newton's law of cooling is not applicable. A metal rod is heated in a furnace. Again, here the heat is being supplied. There is nothing being removed. So this option is also eliminated. A cup of tea is allowed to cool on a table. Here the temperature drops. Heat is going out from coffee to the environment. Yes, here Newton's law is applicable. The correct answer will be option B only. Moving on to the next question. The figure given below shows the direction of two forces P and Q. Okay, P is because of the weight of the astronaut. So let's call this Fw, and Q is because of the air drag. Let's call it Fd. Okay, which of the following statements is correct about the two forces? Force P is caused by gravity and force Q is caused by friction. Yes, maybe this option is correct. Let's look at the other options and then come back to this one. When the force P is bigger than force Q, the speed of the skydiver remains same. If force P is bigger than force Q, no, this option is eliminated because force P cannot be changed. Force P remains constant. If when the force P is bigger than the speed of the kite, no. If force P is bigger, then the astronaut will fall faster. So this option is eliminated out. After the parachute opens, force P remains the same. Yes, force P cannot be changed. Force P will remain the same while force Q increases. Yes, that is why when as soon as you open the parachute, you experience an upward force. So this option may be correct. Let's look at option D. After the parachute opens, force P decreases while force Q increases. And as I have mentioned, force P, that is force because of weight, cannot be changed. So this option is also eliminated. Now, which among A and C will be correct? Now, this question is ambiguous. That is, this question does not have enough clarity to come to the correct answer. But if you look at option A, they have mentioned force P is caused by gravity and force Q is caused by friction. They have just mentioned friction and they have not mentioned air friction. So because of the ambiguity of the question option, we have to eliminate option A and go with option C. Okay, according to me, you should get marks for this, but again, they have not mentioned A in option A, they have not mentioned air friction. The question is ambiguous, and that is why we have to eliminate option A and go with option C. Now we have completed all the solutions for NDA 2 2024. I hope you understood everything. Thank you. Jai Hind.